Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, meet me again. Before continuing, introduce me to Miftachul Jannah from Chemistry Kelas B, Faculty of Science and Technology, UIN Maulana Malik Ibrahim Malang. And here I will explain about the summary sampling strategy and Analyte contamination and reagent contamination. Okay, I will explain first about the sampling strategy. Water and wastewater analysis. Sampling and preservation strategies. Point 1. Sampling is collecting a certain volume of a body of water to be studied with the smallest possible amount. The water sample must be representative and still have the same properties as the condition at the beginning of the collection. Sampling is divided into 3 steps. One step is representative sampling. 2 step, transport and preservation of samples. And last, chemical analysis of samples. Sampling, preparation and preservation. 1. Sample files must be inserted that they do not contain any contaminants from previous measurements. So, we have to be careful because the average concentration that we analyze is very small. Therefore, we need no addition of the container because the former was used in the previous analysis. Must be clean and have been rinsed with distilled water, then processed with the liquid that will be used to fill the water and dry, if possible. Then, sampling tools such as pipes, pumps, etc. must be clean and free from residue from old samples. But if the former is used at much higher concentration, it will usually affect the reading and avoiding the growth of mold and mildew should be prevented. Why should it be prevented? Because mold and mildew can reduce and absorb what we test. Contamination that can dissolve in the sample must be prevented, especially iron, brass, bronze, which can be dissolved in water which is acidic or basic. Meanwhile, plastic or rubber materials that are soluble in industrial wastewater contain organic solvents or oil or gasoline. So, don't choose a container made of plastic and rubber if the sample is organic. Samples can be taken separately using a bucket, plastic or glass bottle with a wick for a sample with a lead ring around the neck. Then, put into rivers, canals, wells, and so on. Taking samples at a certain depth, namely 1. Provided a closed bottle that can be opened if it reaches. Provided a closed bottle that can be opened if it reaches the desired depth. For a sample, river water avoids stocking samples on the surface because there are solid objects floating. And another way can be to use a kind of evaporative pump. Samples from tap water can be taken with an open or closed beaker depending on the analysis. A thematic sampler is a special tool for such safe sampling. This tool consists of suction pipe with a limited sampling point depth of about 5 meters below the tool, and 2 is palm. Then clock to control sampling frequency, a tool for dividing samples into bottles as a sample solution, and an isothermic box containing bottles of mixed samples by cooling by ordinary ice or dry ice so that sample preservation can be carried out no later than 1 day before being brought to the laboratory. And next, the sample should be filled with the collection bottle completely and the bottle tightly closed to avoid contact with air. Because if there is air, it will help the oxidation process in the sample, so hopefully nothing will change. One of the preservation of the sample is generally a cold atmosphere. The sample is transported in an isothermic box containing ordinary ice or dry ice, then stored in the refrigerator or freezer. Disturbance arising during storage and transportation of samples. 1. Oxide and carbon oxide gases that can be absorbed by the sample water or can be removed from the sample water into the air. Colloid suspended substance can form flux and precipitate so that there are samples that are different from the original state. At least the slurry should be suspended evenly before analyzed with a storage bottle. And like substance and liquids can float on the surface. Then some solutes that can be oxidized by dissolved oxygen so that it turns into other compounds. For example, dissolved Mn2+ can be oxidized by oxygen, which can precipitate so that it is lost from the solution. Next, I will explain about Analyte contamination. Contamination is defined as the entry of unwanted compounds into the sample during the initial treatment process of the sample and during analysis. Source of contamination can come from the atmosphere, operators, equipment, water, and reagent. Contamination from the atmosphere derived from particulate trace elements on the soil surface and suspended materials in the atmosphere. A simple way to avoid contamination is to cover the sample solution during the preparation and analysis process. Contamination by operator. The analyzer can be a source of contamination to the sample to be analyzed either by direct contact or by air. From our breath contains NaCl, which can move to the analyte, dust and cigarette smoke, and surge of metal contaminants. Then, source of contaminants can be such as powder, lotion, perfume and operator shoes, etc. etc. Human skin contains low concentration of metals. Contamination from equipment. Glassware such as glass in analytical chemistry, namely Pyrex. Contamination of the sample from the glass due to dissolution of the container by the solution. Preparation equipment that may have a lower metal concentration are 1. Food silica or crates, 2. Plastic, polyethylene and polypropylene, 3. Tetrafluoroethylene polymer, 4. PVC or polyvinyl chloride, 5. Rubber, and 6. Filter paper. Contamination from solvent. Because water is used in very large quantities, it needs to be given special treatment. To reduce metal contamination in water, it is necessary to distill at least 2 eggs or the water is passed first into the resin pool. And then I will explain about contamination of reagent. 1. Mineral acid and ammonia. Mineral acid. Many mineral acids contain certain amounts of metals. Then distinguished levels of extra pure acid which contain metals in low levels with quite expensive prices. Ultra pure, which generally contains a fairly low metal concentration, but the content of some elements varies from product to product. Analytical reagent grade acid which usually contain metals according to the table for the purpose of ultra-trace analysis. The acid can be purified by distillation, and the usual reagent used are HCl, HNO3, H2SO4, and HF. Ammonia solution. Ammonia solution in water placed in glass bottles will be contaminated by silica, aluminum, calcium, and other elements caused by attack by alkaline solution. Analytical reagents for ammonia can contain heavy metals in very low concentration. This is probably caused by the metal absorbed by the glass. And 2. Inorganic solids. With fairly pure reagent, qualities are used directly without pre-purification. However, a blank solution must be prepared as a control, correcting the effect of absorption from the solvent. Lead PB contains solids KCl and ACl, and H4NO3 and KNO3. Purification by means of crystallization or filtration. Then 3. Organic reagent, highly reactive to metals, are called chelators. Contains coordinately bonded metals derived from solvent or reagent used in the synthesis of ligand, usually used in small quantities so that contamination can be ignored. But caution is still needed to avoid unwanted things. And last, organic solvent. The metal content in organic solvent is relatively low, so the presence of other organic compounds dissolved in the solvent interferes with spectrometric determination. And the factor for analyte loss or absorption can be from the container on the analyzer, volatilization, or evaporating, for example, in determining the preparation. Then co-precipitation or settling, for example, storing the material for several days so that the concentration becomes low. What you have to do is shake and add acid to make it more homogeneous. Thank you for watching my summary. And sorry if I mispronunciation words or sentence. And wassalamualaikum warahmatullahi wabarakatuh.